One of the things we have learned about logs is that when we have multiple log terms, we can combine those into one log. But sometimes you will have a situation where you have one log and you want to break it up into multiple log terms. So now we just have to do the opposite of what we did, those 3 rules we learned when we combined multiple log terms into one log. Now we're doing the opposite. Easiest thing is to show you an example. If I have log 4 of x and z, and my instructions read something like this: please express the log in terms of log x, log y, or log z. So what they're saying is, right now I have log of xz, so no, I don't want that. You can only have log x, log y, log z. So in a sense, I'm going to break this up into multiple log terms. So you remember, if you're adding 2 log terms together with the same base, if you turn them into one log, you multiply the arguments. So if I want to take where my argument is 2 things multiplied and break it up into 2 logs, hopefully it becomes rather obvious. Then I can write it like this. Log base 4 of xz, I can now sort of do the opposite of my adding log terms together and in a sense break them up. And it becomes log base 4 of x plus log base 4 of y. I now have expressed my initial log in terms of log of x and log of z, which is what they asked for. Another fairly straightforward example would be log of y over x. I want to break that up into separate logs. Of course, now I have y divided by x, and I recall that in order to get division into log means you subtract. So when I break this up, it's going to be log base 4 of y minus log base 4 of x. Now, let's do some even trickier ones. How about log base 6 of the cube root of z? Now in this case, I'm still only going to have one log, but because they asked me to express it just as log z, I can't have any exponents on my argument. In other words, let's first convert this into a rational exponent. This is going to be the same thing as log base 6 of z to the 1/3. But they told me they want me to express it as just log z. Right now I have log of z 1/3. So now I'm going to do the opposite, where we learned how to sort of get rid of coefficients in front of the log term. And it became an exponent. Now I have an exponent, and I want to, in a sense, get rid of the exponent. So I'm going to now move it and create a coefficient in front of the log. And now I have expressed that in terms of log z. So now I'm simply sort of going backwards in the rules we learned previously. Now we're going backwards. So then you can have increasingly interesting problems like log base a of x cubed w over y squared z to the 4th. I want to break this up into separate logs, log x, log w, log y, log z. So then I realize, well, everything in the numerator is going to be added. So log a of x cubed plus log a of w, and everything in the numerator is going to be subtracted. Log base a of y squared minus log base a of z to the 4th. And now I cannot leave exponents inside the log, so I move them out front as coefficients. So 3 log base a of x. The w, there is no exponent. For this y, I bring the 2 out front, minus 2 log base a of y, and then minus 4 log base a of z. All right, there we go. Now let's do some with some radicals. How about log square root of y over x to the 4th cube root of z. I want to rewrite this and express it in terms of log x, log y, log z. First thing I need to do is convert all the radicals into rational exponents. So this is going to be log square root of y is y to the 1/2. X to the 4th is okay. Cube root of z, z to the 1/3. Now let's go and break this up into separate log terms. So log of y to the 1/2. Now the x to the 4th and z to the 3rd are both in the denominator, so I'm going to subtract them. Minus log x to the 4th minus log z to the 1/3. And now the final step is I have to get rid of those exponents inside the log. So 1/2 log y minus 4 log x minus 1/3 log z. And there we go. Maybe do one last one that I thought looked interesting. Maybe it's not too hard, maybe it will be hard. Let's do a natural log of x times the cube root of y to the 4th over z to the 5th. Wow. First step is, let's get rid of that radical. So I think when we do it, we'll have x of y to the 4/3 over z to the 5/3. And now I can break that up into separate logs. Natural log of x, the y to the 4/3, I add that. As a matter of fact, just to save time, I know the 4/3 is going to come down front. Then I'm going to subtract the z. I know the 5/3 is going to become the coefficient natural log of z. So I guess that wasn't too bad after all. All right, so there are some examples of when you're given one log, you can sort of go backwards and break it up into multiple log terms.